What a, so to solve these distance, rate, and time problems, it's usually nice to set up a table in order to organize the information better. Once I have that set up, the next job is to create an equation, and then we just solve the equation. Um, all right, so anytime I have a distance, rate, and time problem, I'm going to set up a table that looks like this. I'm going to have a distance column, a rate column, and a time column. And typically we have two rows. It doesn't matter what order we put the columns in. So the D is distance, R is rate, and the T is time. And I'm going to work on filling in these boxes. So this problem talks about two trains, a freight train and a passenger train. My first row will represent the freight train, and the second row is going to represent the passenger train. Let's see. The goal of this problem is to figure out how fast each train is traveling. Most of the time on the algebra problems, whatever it is they want me to find out, we often call that x. So they want me to figure out how fast. They want me to figure out the rate of each train. We're told that the passenger train is 40 miles an hour faster than the freight train. So let's see if the freight train, I don't know how fast it's going. I'm going to call that x, but the passenger train is going 40 miles an hour faster than the freight train. So that means it's going to be, we can represent that by the expression x plus 40. Once we read the problem, we see that the freight train had a 2-hour head start, and then 2.5 hours later, the other train, the passenger train catches up. So, you know that both trains are traveling down some track, it sounds like, and after a total time of 4.5 hours, that's where both trains are at the same spot. They traveled the same distance, right? So both trains start at some point. 4.5 hours later, that's where the trains have traveled the same distance, right? The first train has a 2-hour head start, and then 2.5 hours after that, a total of 4.5 hours, the second train has caught up. So notice that the freight train has been traveling for a total time of 4.5 hours, because it had 2 hours head start, and then 2.5 hours after that, the other train caught up. So the freight train, the slower train, has been traveling for 4.5 hours. The passenger train has only been traveling for 2.5 hours, 2.5 hours. Now, we don't know the distances the trains have traveled, but there's a formula that relates distance, rate, and time. Distance equals rate times time. So the distance equals rate times time. I can multiply the two boxes to get the D box. So x times 4.5, I can put 4.5x there. That represents the distance the freight train travels. And distance times time, or rate times time, so 2.5 times x plus 40 goes here. So 4.5x, that represents the distance the freight train has traveled once the other train caught up to it, and 2.5 times x plus 40 represents the distance that the passenger train traveled. The thing is, though, at this time right here, where the passenger train caught up to the freight train, I don't know the distance, but the distances are the same. Both trains have traveled the same distance at that time, right? Both trains started here, and after 4.5 hours, the slow train got to point A, and the fast train eventually got to point A. So that means I can set these two expressions equal to one another, because the two distances that the trains have traveled is the same. So they're equal. I can equate the two expressions. The slow train, of course, took a lot longer to get there, but at this point in time, the two trains have traveled the same distance. I can set those two expressions equal to one another. And now I just solve this. So we'll distribute. So we have 2.5x, and then 2.5 times 40 is 100. and then we minus the 2.5x from both sides. And we get 2x equals 100, and after dividing by 2, I see that x is 50. And x represents the speed of the freight train, so that means the freight train speed is just 50 miles an hour up here, and the passenger train is going x plus 40, or 50 plus 40, and that's where the 90 comes for the speed of the passenger train. So that completes this problem. The hardest part about these word problems is setting them up. And oftentimes when you have the distance, rate, and time problems, it's way too hard to come up with this equation without first organizing the information in a table. And the template of this table never changes. We always have a D, R, and T. We always have D, R, and T columns.